Hi students, welcome to Max Point of View. Today we are going to understand the concept of electromagnetic spectrum and its broad classification. This is part B of the main chapter spectrum. So here we are going to learn the concept. We'll understand the concept, and in this chapter there are many things which are not there in the syllabus. You have to focus on that. That I am going to teach you during the lesson. Now after this one we are going to solve each and every question which is there in the syllabus, and which is not there in the syllabus we are going to skip those questions. So without wasting any time, we'll start with our concept. Before understanding the concept, we need to understand which are the topics are not there in the syllabus. See, when it comes to electromagnetic spectrum, there are many radiation. Out of that, only two are there in the syllabus. Remaining things are not there in the syllabus. So, we're going to focus only on these two radiations. Before that, we need to understand which are not there in the syllabus. We'll come one by one. So, when it comes to spectrum, the definition, okay, electromagnetic spectrum, then common properties. When it comes to electromagnetic spectrum, there is an order. See, this is the order, correct? This order you should know. Okay, we are going to learn only about two these are radiations, but this order, okay, order of increase in wavelength, okay, increase in wavelength you should know. Okay, apart from that you don't have to remember those values also. So only the names, that too in increasing order of wavelength, that is enough. Out of these radiations, okay, we are going to learn only two radiations. What is that? Infrared and UV. So when it comes to infrared and UV, we require only two things: properties and their uses. Properties and their uses, that's it. So when it comes to infrared and UV, we require only two things: properties and their uses, that's it. So we are going to see from the beginning. I'll tell you this, what is the definition of electromagnetic spectrum, electromagnetic radiation. Then this order of increasing frequency, that too without values never, you are not going to remember any value. You just need to know this increasing order of wavelength. See, increasing order of wavelength is nothing but decreasing order of frequency, because wavelength and frequencies are inversely proportional. Okay, this increasing order, then only two things we are going to learn: infrared and UV radiations. So then common properties. Before going to the particular infrared or UV, there is one paragraph, common properties. That common properties are very much important. So in the concept video, okay, I'm going to tell you why it is very much important, how to use it when the question is asked. So once we learn all these things, that's it. Remaining things, gamma, we are not going to learn anything about gamma, microwave, radio wave, nothing. We are going to focus only on infrared and UV. So any questions related to these in the theory solution video also, we are going to skip it. Why? Because it is not there in the syllabus. Now we'll talk about electromagnetic spectrum. See, the meaning is very simple. The combination of both visible and invisible spectrum is called electromagnetic spectrum. The combination of both visible and invisible spectrum. Visible, which we can see, okay, from red to violet, correct? Vibgayar, the colors which we can see, correct? And invisible spectrum. What is invisible spectrum? The part of the spectrum which is beyond red and violet extremes. So after red and violet, there are many radiations which we cannot see. Those are called invisible spectrum. So the combination of both visible and invisible spectrum is called as electromagnetic spectrum. Now we are going to learn the complete electromagnetic spectrum, both visible and invisible, in the increasing order of their wavelength. See, this is very much important. This you have to by heart, and no need to by heart any value, just the order. See, this order you need to by heart, that's it. So, and that too in the increasing order of their wavelength. See, here in this order, the value of wavelength keeps on increasing, okay, and we know wavelength is inversely proportional to frequency. The first radiation has the minimum wavelength and it has the maximum frequency. Why? Because wavelength and frequencies are inversely proportional. So this order is increasing order of their wavelength and decreasing order of their frequency. Keep this in mind. So you have to by heart this order. Next, why we cannot see them? Which one? Invisible spectrum. Why? Because very simple, the invisible spectrum will not produce us the sensation of vision, and actually they harm our eyes. Okay, then which is there in the syllabus? We don't have to learn everything about all these electromagnetic radiations. No, we are going to focus only on infrared radiation and UV radiation. Infrared short form is IR radiation, UV is the short form. Okay, then UV means ultraviolet radiation. Only based on infrared and ultraviolet radiation is there in the syllabus, and not everything about them, only properties and their uses. Detection and sources of infrared and UV radiation are also not there in the syllabus. So listen carefully, you need to understand what is there in the syllabus. You should not keep on studying everything in this there in the textbook. This much about electromagnetic spectrum, that is enough. Now we'll talk about common properties of all the electromagnetic radiation. Why this is so much important? Why? Because in the exam they'll ask you one question about increasing order of their wavelength. That includes all the radiation, correct? So they'll select any two radiations. Out of these two radiation, write the common properties. Then you can write any one. Okay, we have 5 common properties. Whenever they specifically ask, write one common property between any two radiation, any one out of these 5 you can write. Okay, there you don't have to think much about it. So common properties, if they ask you what is the common property between X-ray and gamma rays, you can write any one. Any radiation, you can take any radiation, microwave gamma rays, microwave X-rays, UV rays, infrared rays, any common. If they are asking any one common property, then you can write any one of these. But why we have to learn all the 5? Why? Because they can create any question based on these 5 common properties also. So now we learn the first common property. They don't require material medium to travel. So they can travel in vacuum also. They don't require any material medium to travel. And the second property, in vacuum all the electromagnetic radiation will travel with the same speed. This is in vacuum or air. Okay, vacuum or air, all the electromagnetic spectrum will travel with the same speed, that is nothing but 3 into 10 power 8 meter per second. But in different medium the speed will be different. Keep this in mind. So whenever you are writing, all the electromagnetic radiations have the same speed, you have to mention the medium, that is nothing but vacuum. In different medium they have different speeds. Third point, all the electromagnetic radiation exhibits the properties of reflection and refraction. When it moves from one medium to another medium, see, keep this in mind, we already learned this one. Speed, wavelength, intensity changes except frequency. Frequency will never change. Keep this in mind, because frequency depends upon the source. Speed, intensity, wavelength, all these 3 depends upon the medium. Okay, this is very much important. These electromagnetic radiations will not get deflected by electric and magnetic field. This is one more point. All these electromagnetic radiations are transverse in nature. They are not longitudinal, they are transverse. So what is longitudinal, what is a transverse wave? That is what we have going to learn in sound chapter. Now these are the common properties of all the electromagnetic radiation. This is very much important. In the exam definitely they'll ask you write one common property between IR and UV, gamma and X-ray, anything. You select any one of these things. Which is easier for you, you have to write this one. Apart from this one, if you write anything, you're not going to get marks. We got to know, we are going to learn only about infrared radiation and UV radiation. In that we are going to learn about properties and uses, that's it. Detection and sources, harmful effect, all those things are not there in the syllabus. So first we'll learn about UV radiation. UV means ultraviolet radiation. So in this UV radiation we need to know the wavelength. See, wavelength, the value of wavelength you don't have to remember, but for a safer side, anyhow we are going to learn only 2 radiations, right? So that we can remember the wavelength. Wavelength range, okay, wavelength range of UV radiation is 100 Armstrong to 4000 Armstrong. See, Armstrong is equal to 10 power minus 10 meter. Keep this in mind. 10 power minus 10 meter. Okay. So you can write this value as 10 nanometer to 400 nanometer. See, Armstrong is equal to 10 power minus 10 meter. Okay, nano we know 10 power minus 9. Okay, you can write this one or this one. If they are given any one, you have to identify. See, 99% of the time they will give you the wavelength, okay, range you need to identify. They will never ask you to write this one. They will only give you, you need to identify. For that, we need to remember this value only for UV radiation and infrared radiation. Other radiations, we don't have to remember their uses, properties, detection, sources, harmful effect and their wavelength range also. Only for UV and infrared radiations, that's it. So wavelength range is 100 Armstrong to 4000 Armstrong or 10 nanometer to 400 nanometer. If you compare it properly, then you will get 1 nanometer is equal to 10 Armstrong. 1 nanometer is 10 power minus 9 meter, correct? Armstrong is 10 power minus 10 meter. So into 10 you will get the 10 power minus 9 only. So this relation also you should know. Conversions, that's it. Okay, now we'll go to the properties. First property, very important. See, the properties and uses are very much important. The first property, ultraviolet radiations will pass through quartz. See, keep this in mind. Ultraviolet radiation, UV radiation will pass through quartz. What is quartz? Quartz is almost like glass but not glass. Okay, completely it looks like glass only, but it is not glass. So ultraviolet radiation will pass through quartz, but it will get absorbed by glass. It will get absorbed by normal glass. So to obtain the UV radiations, we use quartz prism. We use quartz prism, not the glass prism. And for the same reason, ultraviolet bulbs, you know, UV bulbs, correct? In that bulbs, the envelope means outer surface is made up of quartz, not made up of glass, because if it is made up of glass, it will get absorbed by the glass. The UV radiation will not come out of this bulb only. So keep this in mind. Quartz is very much important because UV radiation can pass through quartz, but it will get absorbed by glass. That is why we don't use glass when it is related to UV radiation. Our next property, UV radiation travel with the speed of 3 into 10 power 8 meter per second in vacuum or air. See, whenever you are specifying the value, okay, 3 into 10 power 8 meter per second, you have to specify the medium also. So in different medium, they have different speed. This is what we have learnt in common properties of all the electromagnetic radiation. This is one more property of UV radiation. Then these UV radiations will get scattered by the dust particle in the atmosphere. That means it will undergo scattering. Our next property, they obey the laws of reflection and refraction, and these UV radiations will affect the photographic plate. Why? Because these are chemically more active than the visible rays. See, keep one thing in mind, whether UV rays affect the photographic plate. Yes. Why? Because they are chemically more active. That's it. Our last property, these ultraviolet radiation produces fluorescence on striking zinc sulfide screen. So they'll produce fluorescence. What do you mean by fluorescence? Fluorescence is nothing but a bright light which we can see. Okay, even though it is UV radiation, it produces a bright light. Okay, okay, by exciting the atom, that we can see. So these are the properties of UV radiations. Now we learn the uses of UV radiation. These radiations are used to sterilize air and surgical equipments. Sterilizing means killing the microorganisms. So just to clean the equipments in a proper way. Next one, these UV radiations are used to detect the purity of gems, egg and ghee also. These are very useful in producing the vitamin D in foods of plants as well as in animals. So the properties we have learned, these are the uses. So this much is enough to capture the complete marks based on UV radiation. In the same way, we are going to learn about IR radiation now. Now we'll learn everything about infrared radiation. So the wavelength range is 8000 angstrom to 10 power 7 angstrom. So this is the range of wavelength of infrared radiation. Now we'll talk about the properties of infrared radiation. Like UV rays, this will also get absorbed by the glass. UV rays is also absorbed by the glass. IR rays also absorbed by the glass. But UV rays can pass through quartz, but this one infrared radiation can pass through rock salt. So that is the main difference between UV rays and infrared rays. Then the speed of IR radiation in vacuum area is 3 into 10 power 8 meter per second. This is the common property. They obey the both laws of reflection and refraction. IR radiation usually do not affect the ordinary photographic film, but they will affect specially treated photographic films. Keep this in mind. So now see, whenever they are talking about ordinary photographic film, IR radiations will not affect them. Specially treated photographic film will get affected by IR radiations. Keep this in mind. These IR rays are detected using their heating property. Wherever the heating property is there, we can easily identify whether IR radiations are there or not using the blackened bulb thermometer. Blackened bulb thermometer or thermopile. See, thermopile is a device which converts heat energy to electrical energy. So what you need to remember about this property, these IR radiations are identified by using their heating property. And which device we are using to identify this one? Blackened bulb thermometer or thermopile. These IR radiations are scattered least in the atmosphere because they have long wavelength. Our last property, low energy infrared radiations are absorbed by greenhouse gases like carbon dioxide to keep the earth warm. So these are the properties. Now we'll learn the uses of infrared radiations. Uses of infrared radiation. These infrared radiations are used for therapeutic purpose by doctors. What do you mean by therapeutic purpose? Therapeutic means healing purpose. Infrared radiations are used in photography at night. Okay, only at night, and these are used in infrared radiations are used in mist and fog. You know fog, right? So mist and fog, in that we can use infrared radiation. Why? Because it will not scatter much, because it has high wavelength or long wavelength. Infrared lamps are used in dark rooms for developing photography. Why? Because this will not affect the photographic plate. Instead, they produces visibility for the photographic film. Infrared radiations are used as signals in war. Why? Because these are invisible, and as well as these will not get scattered much in the atmosphere. And infrared radiations are used in remote control in TVs and other gadgets. See, these are the properties and uses. See, if you learn this much, okay, in electromagnetic spectrum and its application, that is enough. So what we have learnt, what is the meaning of electromagnetic spectrum, what is invisible spectrum, increasing order of their wavelength. See, I'm telling you, when it comes to properties and uses, they'll ask questions about UV and infrared radiation. But when it comes to increasing order of their wavelength, that you need to by heart. Based on that, they can ask any question. Okay, like which okay, they'll give you the order. One box will be empty. Complete this box using the one electromagnetic radiation. You have to identify that electromagnetic radiation based on the order of the wavelength. And apart from UV rays and infrared radiation, uses, properties, detection and sources of any other radiations are not there in the syllabus. So in the syllabus only UV and infrared radiations. In that, properties and uses, detections, sources, harmful effects are not there in the syllabus. So if you know this much, that is enough to score all the marks related to electromagnetic spectrum. Now we have learned the concept. Immediately go for the theory question. There you will understand what kind of questions they are going to ask in board exam. Thank you.